Welcome to Engage New York, Module 4, Lesson 22. This is the concept development. Our objective is to be able to compare the size of products to the size of their factors. So, remember that as we get started. So, if we were to find the product of 4 over 4 times 12 inches, that's what we're looking at right here. We're going to compare the size of the products in 4 over 4, 3/4, and 5/4. That is our big idea. So let's go ahead, and what I want you to do is I want you to solve these three problems right here. 4 over 4 times 12, 3/4 times 12 inches, and 5/4 times 12 inches. Go ahead and just solve underneath each problem. Because from there, we're going to compare the size of the products you found to the size of the factors that we're using. Give me a second. All right, so 4 over 4 times 12 inches is essentially multiplying by 1, isn't it? So that's going to equal 12, right? All right, let's go over here. 3/4 times 12 inches. Now, let's move down to 5/4 times 12 inches. So 5/4, 5/4. So is that smaller than 1? Bigger than 1? It's larger than 1, right? So let's look at the answers. Did you get 12, 9, and 15? So did multiplying 12 inches by 4 over 4 change the length of the string? No, it did not. The product is equal to 12 inches. We multiplied. So if we went like this, we would have gotten 48/4 inches, which simplifies down to 12 inches, right? That's another way of doing it. Two different ways to solve it. So when we multiply here, we got 48/4, but that's just another name for 12 using a different unit, right? It's 4/4 of the string, all of it. So all of the string. So multiplying by 1 means just one copy of the number. So it stays the same. The other factor just named 1 as a fraction. So it was 1 is just named as 4 over 4 here, but it's still just multiplying by 1. So the size of 12 doesn't change. All right, moving on here. So did multiplying by 3/4 change the size of our other factor, 12 inches? Did it change? Well, the string became shorter because we only took 3/4 parts of it. We only took 3/4 of the parts of it. We got almost all of the 12 inches, but not quite. We wanted 3/4 of it rather than 4/4, so the factor became smaller after we multiplied our product, right? Our product stayed the same here because we were multiplying by 1. here we took a portion of it, right? A portion. We didn't take the whole thing. We didn't want a whole, we weren't taking the whole 12 inches. We were taking part of the 12 inches, right? All right. So we wanted 3/4 of it rather than 4/4, so the factor became smaller after we multiplied. So we got 9 inches this time instead of 12 inches. So 12 inches was shortened here and resized to 9 inches. How can it be that multiplying made 12 inches smaller when I thought multiplication always made numbers become larger? What do you think? Well, we took only part of 12 inches. When you take just part of something, it is smaller than what you start with. We ended up with 3 of the 4 parts, but not the whole thing, right? So adding 3/12, adding 3/4 12 times is going to be smaller than adding 1 the same number of times. So 9 inches is 3/4 as much as 12 inches. Is that true? Yeah, it's true. So let's consider our last expression here. How did multiplying 5/4 change or not change the size of the other factors? The factor of 12 inches. When I talk about changing the factor, are we changing the factor of 12 inches? How would it change the length of the string? Well, the answer to this one was greater than 12 inches because it's more than 4/4. The product was greater than 12 inches. So 5/4 times 12, here's another way of doing it. 64 is 15 inches, another way of doing it. Right? So 15 inches is 5/4 as much as 12 inches. True or false? True. Now, let's come back to this part right here. So when we got 64 and we ended it with 15 inches, we copied a number greater than 1 12 times. The answer had to be greater than copying 1 the same number of times. So 5/4 of the string would be 1/4 longer than the string is now. So 5/4 times 12 is going to be greater than 12. So 15 inches is 5/4 as much as 12 inches. 15 inches is 1 1/4 times as much as 12 inches. Right, because it would be 3/4 more. So if I drew a tape diagram here and divided this into 12, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. And I broke it into 4. So if you break 12 into 4s, you're going to have groups of 3, right? Plus, so here's one whole, right? So here is 3 12s, 6 12s, 9 12s, 12 over 12, plus 1, 2, 3, right? 1, 2, 3, plus 3 more 12s. You would have 3 extra left over, right? So and remember, 3, the third, this is broken up into fourths, right? 1, 2, 3, 4. This is another fourth. So this becomes 1 1/4. fourth. So if we did it out here and we'd have to have 3 more of these. So this is 1/4. So we've compared our products to 1 factor 12 inches, 12 inches each time in each of these expressions. We explain the changes we notice by thinking about the other factor, this factor. 4/4, 3/4, 5/4, right? And we explain the changes we noticed, right? We notice some changes. We can call the other factor a scaling factor. Remember, that was the word that I kept telling you in the last couple lessons. This is such a major priority standard of 5th grade. It's called the idea of scaling, the scaling factor. What I just highlighted is the scaling factor. A scaling factor can change the size of the other factor. This can impact the other factor, right? So let's look at the relationships in these expressions one more time. We multiplied 12 inches by a scaling factor equal to 1. So let's just write that. Scaling factor equal to 1. Okay. What happened to 12 inches? Well, 12 inches did not change. The product was the same size as 12 inches even after we multiplied it. All right, now here, in the expression 3/4 was the scaling factor. So the scaling factor is equal to 3/4. Was the scaling factor more or less than 1? It's less than 1 because 4/4 is equal to 1. So what happened to the length of string when we multiplied by 3/4 instead of 4/4? Well, the 12 inches became shorter, right? And then let's look at the last one, 5/4. In our last expression, what is the scaling factor in this expression? Well, the scaling factor is 5/4. So let me ask you this question. What happened to the length of string? Well, 12 inches got bigger, didn't it? So the product got bigger. The product was larger than 12 inches. All right, so what I want to do is let's take a little bit of space and let's write something out. So we're going to take this and we're going to write something right in here. Okay. All right. So when you multiply a fraction by a scaling factor, let's say less than 1, comma, equal to 1, comma, or greater than 1, the product is impacted. Well, except for what is equal to 1. All right, so all right, now I'm going to change colors and we're going to write something out. So if I have 3/4 and I multiply by 4/4, the product what? Stays the same, right? If I have 3/4 and I multiply by, let's say, 5/4 again, the product what? And when the product over here, it gets bigger. So this is the big idea of this entire lesson is, do you understand the scaling factor and how the scaling factor impacts the product? So that now we have 3/4 times what? Let's go 1/4. So what's the scaling factor here? 4/4 or 1. What's the scaling factor here? 5/4. It's greater than 1, so the product gets bigger. Now I have 3/4, which is a factor, but it's being scaled by 1/4. So the product is going to what? It's going to get smaller. Your product gets smaller. Big, 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 big idea right here. This is the crux of the lesson. So let's keep going. Let's do a few more. All right, so now we have 4/4 times 1/3, 3/4 times 1/3, 5/4 times 1/3. Without solving, can you tell me what is going to happen to 1/3 in this situation? What is going to happen to 1/3 when it's being scaled by 4/4? It's going to stay the same, right? So I want you to consider the relationships we just noticed between the products and the factors. Now, go through really fast. I want you to solve these 3 problems, and then we're going to go through again and talk about it again. Go ahead and begin. All right, are you done evaluating these expressions or equations, because I added the equal sign? So let's just quickly compare the products that you found to this. All right, so if we solved here, we can multiply. I'll do this. Well, I'm going to go 4 times 1 is 4. 4 times 3 is 12. And this reduces down or simplifies to all right, so when you compare the products that you found to this vector, 1/3, what is the product of 1/3 and 4/4? Well, it's 4/12. So did the size of 1/3 change when we multiplied it by a scaling factor equal to 1? No. So 4/4 times 1/3 is equal to 1/3, right? Perfect. Okay, so the scaling factor is it is equal to 1. It is equal to 1. So our product remained the same. Now, on a test or a quiz, this might be the answer that you have to write out. I don't need to know this. I need to know if you understand what scaling factor is. The scaling factor is multiplying by a fraction that's either less than 1, equal to 1, or greater than 1, and how it impacts the product, right? All right, so since we're comparing our product to 1/3, here, what is the scaling factor in this expression? Our scaling factor is 3/4, right? So is this scaling factor more than or less than 1? You're right, it's less than 1. So what happens to the size of our product when we multiply by a scaling factor less than 1? Well, we end up with 3/12, right? And if you simplify 3/12, you end up with a number smaller than your original factor, right? So we're comparing this product to this factor. We're comparing this product to this factor. So this is the scaling factor that's impacting the factor here. But when you multiply by 1, you end up with exactly the same thing. When you multiply a factor by a scaling factor less than 1, what happens to your product? Your product is less than your factor you started with. So, scaling factor is less than 1. So, our product is less than our original factor of 1/3. All right, let's take a look now so let's just make sure you understand this. So what happened at the size of 1/3 when we multiplied by a scaling factor less than 1? The product was 3/12. That is less than 1/3, which is 4/12. We only wanted part of 1/3 this time, so the answer had to be smaller than 1/3. When you multiply by less than 1, the product is smaller than what you started with, right? All right. So in this last equation expression here, without the equal sign, it's an expression. With the equal sign, it's an equation. So 5/4 times 1/3. So what is the scaling factor? The scaling factor is 5/4, right? So is the scaling factor more than or less than 1? It's more than 1. So 1/3 times 5/4 is equal to what? Well, 5/12, right? 5/12 more or less than equal to 1/3. So remember, if we had our tape diagram and we had 1/3, 1/3 would be how much? Would only be equal to 4. So if this is 12, you would have 4, 4, 4, right? So it would be 1/4, but this is 5/12, so it's more than, right? So our scaling factor is greater than 1, so our product is greater than our original factor of 1/3. So this, we're comparing to the factor we started with. So the scaling factor is greater than 1, so our product is greater than our original factor. Yes? All right. Here is our last group of problems right here. Okay, this time we're going to work with the product half. So we have 1/2. So we're going to start with 1/2. The expressions or equations will have different scaling factors. Think about what will happen to the size of 1/2 when it is multiplied by the scaling factor. So you need to be able to write what is the scaling factor and how did it impact the original factor. Okay? So I want you to be able to tell me tell whether the product will be equal to 1/2, more than 1/2, or less than 1/2. Go ahead and you are going to do 1/2 times 5/5, 1/2 times 3/5, 1/2 times 9/5. Remember, you have to be able to tell me what the scaling factor is and how your product relates to the original factor. Go ahead and begin. All right, let's see what you wrote. Let's see what arrows you drew. Let's see what you circled. Okay, here is our original product. That is what we're comparing to our scaling factor, right? So when we take our factor and we scale it, and we're scaling our factor to 1 essentially, we end up with the same factor, correct? So scaling factor is equal to 1. So our product is the same as our original factor of 1/2. So notice my little arrow showing that my answer goes right straight back. All right, so now, starting with our factor of 1/2, we're using the scaling factor of 3/5. Excuse me, we end up with 3/10. So what happened? Our scaling factor is less than 1. So our product is less than our original factor of 1/2. 3/10 is smaller than 1/2 because 1/2 would be 5/10, and 5/10 is clearly greater than 3/10. All right. Now, what is our original factor? What is our scaling factor? So we end up with 9/10. 9/10 is clearly greater than 5/10 because if we were doing equivalent, we would change this to 5/10, right? So 9/10 is greater than 1/2, correct? So our scaling factor is greater than 1. So our product is greater than our original factor of 1/2. So the big idea here is, can you identify that and can you say that? Can you write it out? That's what you need to be able to do. Okay, last problem of lesson 22. Okay. So, at the book fair, Vlad spends all of his money on new books. Pamela spends 2/3 as much as Vlad. Eli spends 4/3 as much as Vlad. Who spent the most? Okay, so think about this. Here's Vlad. And I notice in our problem, we have third and we have 4/3, right? So here's Vlad. And Vlad spends all his money, all of his money. So he spent 3/3 of his money on books, right? Pamela spends 2/3 of her money, and Eli spends 4/3. So, who spent the most money? Who spent the least amount of money? So, based on what you know, so we are comparing the money of Vlad to Pamela to Eli, right? So when we draw these tape diagrams, the reason why I use thirds is because I looked at 2/3 and 4/3, and I knew I had to work in thirds. So it says Vlad spent all of his money. So all of his money would mean 3/3, right? So Vlad spent all of his money at the big book fair. We drew a tape diagram and labeled it Vlad, right? Then we have Pamela, then we have Eli. What can you tell me based on who spent the most money and who spent the least amount of money? I want you to write out what you know right here and then come back and we'll talk about it. Okay, so hopefully you wrote Eli spent 4/3 of his money and 4/3 is greater than 1. We know that Vlad spent 3/3 of his money, and I'm going to go back up to here, and 4/3 of Eli. No, okay. How should I write this? Okay. Spent all 3/3 of his money, which equals all of his money. Okay. Now, just based on looking at these tape diagrams, who can you say spent the most money? Well, Eli spent the most money because he spent more than one whole. He spent more than Vlad, right? So Eli spent the most money. Now, does our tape diagram show enough information to see who spent the least money at the book fair? Well, yes, it's very easy to see whose tape diagram is the longest and the shortest. Even though we don't know exactly how much Vlad spent, we can still answer the question. Since the scaling factors are more than 1 and less than 1, we know who spent the most and we know who spent the least. So Eli spent the most money and Pamela spent the least money. So we didn't even have to solve anything. All we had to do was think about the numbers, and just drawing out that tape diagram really just answered that whole problem for us. Okay, are you ready to take on the problem set? All right, solve for the unknown. Rewrite each phrase as a multiplication sentence. So you're rewriting this as a multiplication sentence, okay? An expression or an equation, right? for both of these and then solve. And then it says to circle the scaling factor and put a box around the number of meters. So make sure you're answering all the questions. All right, here, draw a tape diagram to model each situation in problem 1 and describe what happened to the number of meters when it was multiplied by the scaling factor. So just like we did in the last problem with Vlad and the book fair, just draw it out. So you're going to model the situation and describe what happened to the number of meters when it was multiplied by the scaling factor. Okay. Then fill in the blank with a numerator or denominator to make the number sentence true. Really easy. Then look at the inequalities in each box. Choose a single fraction to write in all 3 blanks that would make all 3 number sentences true. And then we have 3 word problems. Johnny says multiplication always makes numbers bigger. Wait a minute. We've just been talking about that, right? So Johnny says multiplication always makes numbers bigger. Explain to Johnny why this isn't true. Okay, this is your opportunity to tell me all 3 of those about those 3 scaling factors. Number 6, a company uses a sketch to plan an advertisement on the side of a building. The lettering on the sketch is 3/4 inch tall. In the actual advertisement, the letters must be 34 times as tall. How tall will the letters be on the building? So 34 times taller than 3/4 of an inch. 34 times taller than 3/4 of an inch. 34, let's go back to what we know. What have we been doing? 34 times what? 3/4, right? Okay. Will give us the size. All right, final question. Jason is drawing the floor plan of his bedroom. He is drawing everything with dimensions that are 1/12 the actual size. His bed measures 6 by 3 feet, and the room measures 14 by 16 feet. What are the dimensions of his bed and his room in his drawing? So you need to find 1/12 of what? You need to find 1/12 of his bed and his room, right? So 1/12 of, you have to find 1/12 of 16 and 14, and then 6 and 3. So, and then figure out based on that, what is that going to be based on his drawing? All right, I'm sure you'll be fine. Make sure to complete the problem set independently and then come back to check your work. Remember, you won't know if you actually understand something unless you actually attempt it and try it yourself. All right, good luck.